Fam, welcome to another lesson. Today we're going to do a bit of trigonometry. So I chose this question because I've noticed that students are struggling with question 3.2.2. It is to find sec theta plus sine squared theta. And because we're working with trigonometric ratios like sine theta, cos theta, and tan theta, we have to construct a right triangle because trigonometric ratios concerns itself with right angle triangles. So it's possible to construct a right triangle with the information provided. So let's go ahead and do that. So here's my right angle triangle, and the x coordinate is -3 and the y coordinate is -4. So x is -3 units away from the origin and y is -4 units away from the origin. So in other words, from here to here is 3 units away, and from this point to that point is 4 units away. So now we can find the distance OS by using Pythagoras Theorem because we're working with a right angle triangle. So according to Pythagoras Theorem, the square of the hypotenuse is equal to the sum of the squares of the other two sides. So it's just a matter of substituting. -3 squared plus -4 squared. This is 9 plus 16. Therefore, r squared should be equals to 25, and r should be equals to plus minus square root of 25. So it implies that r should be equals to 5. So r is 5 units. So the length of OS, which is r, is equals to 5 units. So let's define all the sides with respect to this angle theta. So with respect to this angle theta, this side is the opposite because it's right across theta, and the side adjacent next to it is x is equals to -3. It's the adjacent side, and the longer side is the hypotenuse. So now it's possible to define the basic trigonometric ratios. We do so by using SOH CAH TOA. So with information given and the acronym, we can define sine of theta, the angle, is equals to the opposite side over the hypotenuse, and those lengths are given with the opposite side being -4 and the hypotenuse being 5. So already we have some information concerning the second part of this expression. So now we can define sine squared theta. Sine squared theta is also the same as sine theta the whole squared. And now we can substitute sine theta inside the brackets, so it's -4 over 5 to the whole squared. So this is equals to 16 over 25. So this part of the expression we have worked out already. So this can be substituted with 16 over 25. So now the objective is to find sec theta, but we know there's a relationship between sec theta and cos theta. They are reciprocals of each other, so we can work sec theta out from cos theta. So by definition, cos of a given angle is equals to the adjacent side over the hypotenuse. And we know that sec theta is equals to 1 over cos theta. So this is 1 over the adjacent side divided by the hypotenuse, equals to 1 over 1 times hypotenuse over the adjacent side, and this should be given as the hypotenuse over the adjacent side. So essentially sec theta is the hypotenuse over the adjacent side. So now we can just substitute sec theta. The hypotenuse being 5, and the adjacent side being -3. So now we can substitute, we can replace this with 5 over -3. 5 over -3. So let me just rewrite this. So now we can work with the lowest common multiple. The lowest common multiple of the denominators, 25 and -3, or let's just say 3, by moving this negative to the top. So the lowest common multiple is 75. So it's 75. So 3 goes into 75 25 times, minus 5 plus, and 25 goes into 75 3 times. So that should be equals to 25 times -5 is -125 plus 3 times 16, 316, 48, and that should give us minus 77 over 75. Thank you so much for watching.